Welcome to lecture number 37 on electrical machines 1, and we have started discussing about three-phase transformer connections. And I have told you a three-phase transformer can be constituted by using three identical single-phase transformers or as a single unit of three-phase transformers. So, to begin with, I have started of taking three identical single phase transformers and trying to connect them externally, so that a balanced three phase voltage can be transformed into another balanced three phase voltage in the secondary. But while doing so, we should be knowing the dot markings or polarities of the transformers, and we should be systematic in describing the current. In my last lecture, we were seeing that there is a shift in the secondary voltage with respect to the primary voltage, and how that shifting, by what angle the voltages shift, that is called the that is generally written on the nameplate of a three phase transformer, and that is called vector grouping. So, we were up to that, but recall that. So, this was the thing. So, you have a three phase transformer, and once again very quickly I will tell, these are, suppose this is one transformer A. It has got a primary terminals A1, A2, and this is small a1, A2 is the secondary terminal. Similarly, you have the second transformer B, and it has got its primary capital B1, B2, and correspondingly its secondary, and C1, C2, and this is small c1, c2. Okay. And then you have the supply three terminals, okay, that is AS, BS, and CS. Okay. Now, I have to connect the supply and connect this primary and secondary in a particular fashion as desired. And I told you that while connecting the transformers in star, windings in star, either A2, B2, C2 should be shorted, or A1, B1, C1 can be shorted, valid star connections. And also remember, these one terminals are dots, like polarities at any given instant of time. Similarly, for the transformer B and transformer C, and this how do I get? I will test for polarity to this individual transformers, put the dots and mark the terminals accordingly. Anyway, this is how the thing is. So, suppose I say that I will connect the transformer primary in star. I would like to connect this in star or Y, and secondary I would like to connect it in delta, or in later it is small d. Okay. And I will of course make valid connections. So, what I do is this, I make a valid star connection A2, B2, C2 shorted, and I will connect A1 with AS, B1 with BS, and C1 with CS. And suppose the phase sequence of supply, phase sequence is AS, BS, CS, ABC. A stands for supply. Now, the easier way of connecting this I will going to tell you now. We have seen the interesting features. If somebody connects differently, what is going to happen and things like that. Now, today's lecture is all valid connections we will be doing. Okay. The moment you do this, then what you say, and phase sequence is this and supply is balanced. Supply is balanced. Okay. If the supply is balanced, then it is best thing to do is draw the supply voltage first. Okay. So, I draw the supply voltage, which will be equal to like this, 120-degree apart, equal lengths, and this is suppose AS, BS and CS. All lengths are equal, sir, balanced. Okay. And note that AS is connected to A1, then I will write it is also A1, is not this point. Similarly, BS is connected to B1, so comma B1, and CS is connected to C1 comma C1. And since A2, B2, C2 are shorted, so A2 is here, B2 is there, C2 is there. They are shorted, so their potentials are same, and this in fact is the neutral of this side. Fine. Now, suppose the secondary side I would like to connect it in delta, and there are two possible deltas, two possible delta connections are there. So, first of all I will connect it suppose like this. Like this, series and closed, and output I will take from A1, wherever A1 is there, B1 and C1. Let this secondary output be A, B and small c. I am not writing S because it will go to load. Okay. Now, based on this you can easily see the secondary voltages will be, since voltage applied across the primary of transformer A is A1 A2, therefore, this side you have the secondary voltage small A1 A2 which will be parallel to this length. So, I write it like this, A1 A2, got the point, parallel to capital A1 A2. Similarly, small B1 B2, the induced voltage in the secondary will be parallel to this B1 B2 and B2 A2 are shorted. Therefore, how to place this? So, B1 B2, okay, and B1 is connected to A2. So, B1 B2 will be like this here. I am just drawing B1 B2 parallel to this it is available, but I have joined A2 with B1. So, I will shift this fellow parallelly and bring it here like this, such that it A2 and B2 B1 are joined. So, I must write it here B1. So, B1 A2 is this point. So, B1 B2, got the point, parallel to this. Similarly, C1 C2 and C1 is joined with B2, therefore, this phasor should be parallelly shifted and it must be this that is B 2 is connected to C 1. So, C 1 C 2, got the point, and this is absolutely fine. Now, output, see, this is input A 1 is connected to A s, B 1 is connected to B s, C 1 C s. Similarly, I would like to take the output from small a 1, B 1 and C 1. So, I circle them just okay. This will be my output A 1, B 1 and C 1, although B 2 is connected, but I will call it my A, this one A 1 and C 2 are joined. From this I am taking the output, I am calling this A to be consistent with the primary side. Okay. So, that is the thing. Now, the question is, if you connect like this, I should write it as star, secondary is delta. Now, what is the phase angle? What should I write? Now, while doing the phase angle, you can find out first where is the artificial neutral of the secondary side. Got the point? So, this is the neutral. Okay. So, you see that this will be the so this triangle we have identified A 1, B 1, C 1. Similarly, you circle the primaries A 1, with respect to this we will be talking. Now, I will examine with respect to neutral on the primary side, there is A 1 voltage. Similarly, with respect to this artificial neutral, which is centroid of this equilateral triangle, and with respect to that neutral, the phase voltage is this phasor A 1 n. Then you draw this capital A 1 n here. You suppose thing this primary phase voltage with respect to its neutral is here A 1. You should not make confusion that capital N and small n is connected. No, small n is not there in fact. But anyway, that is the A 1 phase vector, if I that is vertical. So, I find that this voltage lacks the phase voltage with respect to the neutral on the phase side by 30 degree, and this is the thing. And I then write it as it is lagging. So, maybe minus 30 degree I will be telling it. But one important thing also, you note that it is not only the phase voltages, that is A 1 with respect to neutral, that maintains 30 degree. What about the line to line voltage? For example, primary side line to line voltage A 1 B 1, because phase sequence is this. So, this voltage is A 1 B 1, which happens to be equal to A s B s. This is the line to line voltage. On the secondary side, what is the line to line voltage? It is this vertical line, and this line to line voltage too this is A 1 B 1. If you just that is also 30 degree lagging. Not only the phase voltage with respect to the neutral or artificial neutral, that will lag, which also means that line to line voltages too will be lagging by the same amount. This point you must understand, because this is A 1 B 1 line to line voltage on the primary side, your small a 1 B 1 becomes vertical A B voltage of the same line to line voltage, that lags. It will be true, as you can see, for B C and CFAs as well. So, examine only the lag or lead with respect to a particular set of line to line voltage. That is the thing I wanted to tell. So, this is the connection then YD minus 30 degree. Acha, now sometimes this vector grouping, this is the vector group. Okay. Is also expressed in terms of a clock, minute and hour hand positions, angle between them, that is how. So, I will first explain that, then explore more interesting connections after that. So, first clock convention, vector group, which is can be also expressed instead of showing the angles by clock conventions, clock convention. Okay. So, you let me go to next page, and you see you have a clock here. Let me explain that, then I will go there. Suppose you have a clock. Clock, of course, you have got all the markings here 1, 3, 6 here and 9. Okay, 1, 3, 6, 9, and of course, no, it is 12, 12, 3, 6, 9. Then you have in between, of course, 1 and 2, 3, 4 and 5, and 7 and 8, and 9, 10 and 11. This is usual clock, our familiar clock. Okay. And there will be two hands, hour hands and minute hand. Minute hand is longer. So, minute hand is suppose in the position of 12. Hour hand could be anywhere in our usual clock. I mean that will, I mean minute and hour hand both can be anywhere, and you get the time. But here, while following this clock convention to describe what is the vector group of the transformer, you note that the angle between two consecutive numbers on the dial of the clock is 30 degree, that is known. That is, this angle is 30, consecutive to any numbers you take 30 degree. Now, what is done is this, the minute hand is shown at 12, always you show it, and let this minute hand represents the primary side, say Fs voltage, with respect to neutral, that is this voltage ASN or A1N, that is the primary side neutral voltage. That voltage I will place in the minute hand and always show it in the 12th position of the clock. This is the primary voltage. Okay. And secondary voltage I will once again this is suppose AS, A1 or AS, either of them with respect to neutral. Similarly, show the hour hand representing the secondary A or A1 voltage with respect to neutral of the secondary side, For delta connection, use artificial neutral. That is small n. This is capital N. You have got the point. For example, the previous connection, minute hand is at 12 vertical, A1 capital N, and secondary FS voltage, this A1 is once again A, which is going to load. So, this is A or A1 with respect to neutral. This is my B, this is my C. Therefore, this A phase voltage, now this angle being 30 degree, where do you think in the clock should I show this secondary voltage? At 1, is not? Because we have seen that secondary voltage is doing this. So, this minute hand, which is bigger, it is capital A1 N and this is small A1 N. I should not write this, but I am writing. You should not be under the impression that if I write like this, I am meaning capital N and small n are shorted. No, it is just separate two things, because two neutrals are located at different positions and they are not connected electrically, but just to indicate what does this mean. Anyway, this is the thing. Then I will write it as primary star connected Y, secondary is delta connected delta. Earlier I wrote it minus 30 degree in the previous page. This is same as Y D 1, that is the time is 1, then only this connection, I mean this is the connection Y D 1, it simply means that the with respect to neutral of a particular phase, primary side voltage and secondary voltage, how they are dispersed. But since our end I will always represent to indicate the secondary voltage, therefore, secondary voltage lags the primary voltage by 30 degree. Okay. So, this is the vector group. For example, this I will just write, for example, Y, we have seen that Y Y, with different color let me write, because so much space is there. For example, this connection I will not redraw, y 0 degree we have seen. What does this mean? It means, okay, these are the primaries, you short this, these are the secondaries, this is A1, A2, A1, A2, B1, B2, etc., C1, C2, small c1, c2 and B1, B2. And suppose you make star star, then this connection indicates it is y by 0 degree, means I will write it as what? Then this voltage A1n, both minute and hour hand will be together. So, I will write it as y 12, time is 12, then only I will say this is y by 0 degree. Similarly, if you short this, I should have written y by 6, because secondary voltage should have been with respect to neutral. Here primary voltage is there, they would have been 180 degree out of phase. I hope you have understood this one. Now, let us try some more connections. Another connection is, previously let me draw another one, so that with delta connections you become comfortable. Suppose there are two ways of delta connection, either this way or other ways, that is cyclically you go this, or it could be connected like this. So, the second connection let me try. What is this? So, once again start delta connection. Okay. So, these are the primaries. A1, A2, B1, these are the primaries, B2, C1, C2s, and these are the secondaries, small a1, A2, small b1, b2 and small c1, c2. Okay. And suppose I have shorted this. So, I get the primary voltages as supply voltages are, this is S, this is Bs, easier way of drawing I am telling Cs. So, supply voltage is balanced, draw As, Bs, Cs first, 120 degree apart, and this is As, Bs, Cs. You draw, and this will become the neutral, and where A2, B2, C2 are joined, this is capital N. This is over. Then you connect it, suppose like this, you join other way now. And mind you, these are dots, do not forget to show that, which I have already told you, that is important. So, you connect this closed circuit, there will be no circulating current, because I have been very meticulous, very careful about polarity marking, and that is why I am connecting, and this is my output terminal, small a, small b, which will go to load, 3-phase load, like that. Now, in this case, the secondary voltage I am now drawing. Secondary voltage will be, mind you, this A S is nothing but your A1, is not, this is nothing but A1. B S is nothing but B 1 and C s is nothing but C 1. Now, I will sketch the secondary voltage. Now, you see there is the voltage A 1 A 2 which will be parallel to A 1 A 2. So, I draw it here, space is there. This is suppose A 1 A 2, it must be like that. This is B, sir. This is B. Acha. Then B 1 B 2 parallel to that the secondary voltage has been induced, that I get from single phase funda, that is induced voltages in each transformers will be cophasal with the primary voltage, that we know from. So, B 1 B 2, but this time I have joined B 2 with B 1. So, move this B 2 with B 1. So, it must be like this. I will first write this A 1 A 2 here, this side A 1 A 2, fine with this. Then B 1 B 2 I will draw like this. With a little practice, you will become conversant with this. This is the thing, A 1 B 2 I have joined. So, they must be at same potential, and then C 1 C 2, and C 1 is joined with A 2. So, it is like this, C 1 C 2, is not. So, it is a valid delta connection, and then I am telling mark this, please follow the instructions carefully, so that you will never make mistake while working with a 3-phase transformer in the laboratory or in the site. So, A 1 B 1 C 1, these are the things, this is A, this is my B, this is C. So, balanced 3-phase voltage will be obtained. So, here is the artificial neutral, because delta connection, no neutral. So, A phase voltage with respect to this neutral, and A phase voltage of the primary is this vertical line, therefore, it is 30 degree. So, in terms of clock it will become this 12, 6, 3, 9, 10, 11, etc. 1, 2, 4, 5, 7, 8. Okay. So, primary voltage with the minute hand I will always show. So, that was this, and secondary voltage with respect to same A phase voltage with respect to neutral is now ahead of this. So, it must be shown here, our end, this is the secondary voltage and this is 30 degree. So, this connection I should say it is Y D plus 30 degree, or you show Y D 11 like that. Okay, we will continue with this, try to understand, very interesting, but at the same time people often make confusion. I mean, thank you.